Today we're going to talk about water quality, water treatment. How do you tell that water is safe to drink or not? The first diagram at the top, this has a picture of a system where they use the sensor and send information back. This one measures dissolved oxygen, it measures turbidity, it measures temperature, and it measures pH. Many of the things that we did outside way back last year. So let's look at the answers to these together. Water monitoring is important to maintain water health. The amount of sediment, whether that's soil, whether it's dead stuff like leaves in the water, to make the water less clear, this is the turbidity of the water. Turbidity, if low turbidity is clear, high turbidity would be very hard to see through. If you can't see through it, the sun also can't shine through it, which means that the plants can't make oxygen to make the dissolved oxygen level high enough for the water to be healthy. If you clean up the organic matter, this is a way of a fancy word called mitigation. Mitigation is just a process of cleaning up a pollution problem. So the measurement of whether water is acidic or basic is called pH. This percent hydrogen, but pH. That's why we write it. Lowercase p, capital H. The scale of pH 1 to 6.9 is acidic, 7 is neutral, 7.1 to 14 is basic. Water pH is best if it's between 6 and 8 on that scale. Water temperature should be similar to the outside temperature. If the temperature is above 85 degrees, then it will impact the amount of dissolved oxygen. Dissolved oxygen is necessary for plants, necessary for the animals in the water to live. So, very important. If there's bamboo and kudzu and other organisms just growing anywhere in a habitat where they're not supposed to be, they are considered invasive species. Just like somebody comes and kicks in your door and invades your house, they are an intruder, they're invasive, they're invading you. So an invasive species. These species impact because they take up space where other things should grow and take the nutrients away. Kind of like weeds in a field. If you take a right and go towards Buckhorn out of the school, you'll see a big crop of bamboo that we walk beside during our outside lab that grow all the way almost to West 10. It's just taking over all kinds of space. So those are invasive species. Okay. Now, scientists are sometimes assigned to reservoirs, which we learned last Friday, are anything that holds water or running waters to monitor. That's why you determine the health of something. Okay. Some people monitor their diabetes or calorie intake, whatever. But if you monitor the water, it's very expensive to do all kind of testing on water all the time. Scientists have figured out that there are little organisms that like mayflies, if you see in the picture over here, they're examples of sensitive bioindicators that are very sensitive to oxygen. If they're present and they see the mayfly or whatever it is out in the water, then they don't have to test the water at all because they know that these things would be not present if the water was not good. If they're not present, they will need to take it back and check for pollution related items that may be present. Okay. All right. In North Carolina, there is a bad problem. We're going to get rid of this line right here just for fun. In North Carolina, there's a problem that's been mentioned many times, and you'll hear about hog lagoons if you listen to the news, like nerds like me do, other people that want to know what's going on. But runoff's a problem. There's hog lagoons where they raise lots and lots of pigs. Lots of pigs like to poop. They sometimes die. They sometimes all kind of things happen in there. And it's fine as long as it stays within the banks of that lagoon. When events like happened last year with the hurricane that hit down around New Bern and came up through farms, those lagoons went over their banks, and the runoff went into the rivers, and the rivers all went down to the ocean, and there was great amounts of pollution in there, a big problem. So excess water causes these things to overflow their banks and run off. We usually can't point to one location of this is a non-point source, because you really can't point to exactly where it came from. Because all of a sudden you see things from the street, you see things from housing development, from a feedlot, all come down from a farmland, might come from the forest or homes out in the woods. And all you know is there's pollution. You don't know exactly where it came from. You can't point to a pipe and say, oh, there's a pipe where it leaked from, or an underground pipe it leaked from. So that's called a non-point source, because you cannot point at it. When pollution happens from distances away, they cannot easily be detected. Again, this is non-point source. It can't easily be detected where it came from. It's non-point source. Runoff from cropland, like here, can bring excess nitrates in the form of fertilizer. This is a problem. Talk about in a minute why it's a problem. Phosphates can come from animal waste, they can come from human waste, can come from runoff from cleaning products or laundry products. That's why they don't like you to advise you against washing your car at home, but go to a place where they recycle and clean up the soap and products and let soap just run off into the water. Because if there's excess nitrates and phosphates, it can lead to what we call algal growth. You may know anything about an algae eater if you have a fish tank or something, but sometimes on the top of the pond it'll grow and it looks like it's covered with tennis ball felt. Have you ever seen a tennis ball? Look on the bottom of a few of my chairs or something. The whole top of the pond will turn that color. When these algal blooms, just an adjectival form of algae, cover the surface of the pond, just like the aphotic zone in the ocean, the sunlight can't penetrate. Water plants cannot make oxygen, which is a problem. This leads to decreased amounts of dissolved oxygen. We just mentioned a little while ago. Too many S's. And if it gets low enough, it can lead to death of all life in the pond. Then you just have a water hole that's dead. Everything's dead. Very sad. Here's a diagram about point source pollution, where you know exactly where the stuff's coming from. You can see it's coming out of the smokestack. You know that it's coming out of some seepage of a tank on this farm. You can see the wastewater coming from a pipe from here. It might seep directly through the ground if somebody spills oil in their backyard or something. But pollution comes from many ways. Point source can be defined as any identifiable. You can point at it, you can identify its source of pollution from which pollutants are discharged, such as a pipe, a ditch, a ship, or a factory smokestack. Point sources is due from a leak from a pipe or a smokestack that hasn't been cleaned or doesn't have proper filters. So this is our plan for the day. Go back and review these ideas of how we know that water is healthy, and also the two different types of pollution and how they can be mitigated. Okay.